Okay, today we are going to do the intro to quadratics. First of all, let's just do a little bit of background on where quadratics come from. Up until now, what we have done is linear. So when you had y equals 1/2 x minus 3, that is a linear equation. And when we graph this, we had the y-intercept of 0 and -3. Slope of 1/2 meant up 1 and to the right 2, and up 1 to the right 2. So because it is a linear equation, all of our graphs were lines. Now when we get into quadratics, our quadratics graphs are called parabolas. And for Algebra 1-2, our parabolas are going to look primarily like this, or primarily like that. Okay, so this would be called opening up, and this would be called opening down. When you get into Algebra 3-4, that's when you start seeing parabolas that are on their side. Okay, so we are not worrying about these right now. Okay, just to know that those do exist, however. When you have a parabola, the neat thing about parabolas is that no matter where it's at, there is what is called an axis of symmetry. And that axis of symmetry is what cuts the parabola in half. So, for example, this point here, there is another point across from it that if you were to fold this parabola in half, it would be mapped onto each other. So if you had this point here, I know that there is another one right over here as well, going off the axis of symmetry. Make sure you're not following just the y-axis, but you're looking at the axis of symmetry. Okay, when we are talking about a parabola, if you have a parabola that looks like that, it opens up, the lowest point of your parabola, this is called the vertex, and when the parabola opens up like this, this is also called the minimum. Okay, so the lowest or highest point called the vertex, but when it opens up, it is called the minimum. And if you have a parabola that opens this direction, this is also called the vertex, but in this particular graph, it is called the maximum. Okay, so minimum, max. So a lot of times we'll just say min and we'll say max. Okay. We have what is called standard form. And standard form of a quadratic is f of x equals ax squared plus bx plus c. And there are certain things that the a performs and that the c performs. So if we are graphing a parabola, this is going to be the standard form. There is something that we're going to talk a little bit more about later, and that is called vertex form. And that is f of x equals a times the quantity of x minus h, that quantity squared, plus k. And we'll talk about that completely in another lesson. Okay? So we are going to deal primarily first with standard form. Okay, so with standard form, if we have f of x, and again, if you change it to y, that is fine. Okay, so if we are dealing with standard form, I want to find an equation that is in standard form that we can graph. If you remember from factoring, we focused on identifying the A and the B and the C. That's exactly what we're going to start off with here as well. So if we have, let me find a good example. Let's see. I'm not finding what I want. Just a minute. So if we have y equals x squared minus x minus 2, the first thing you're going to want to do is identify your A, your B, and your C. I am kind of picky about this. Make sure you put equal signs, because if you just put a hyphen or a dash, I don't know if the dash is representing, hey, here's my number, or if it's representing the negative piece. The A is always in front of the squared or the quadratic term. So A here is an understood 1. B is always in front of the x, so that is a negative 1. And the C is the number that tails at the end. So that is a negative 2. If we have something like y equals 3x squared minus 4, and you identify your A and your B and your C, same thing still applies. The A is in front of the squared or the quadratic term, so it'd be a 3. But where is my B? B is in front of the x, but we don't have an x or a linear term. So it is a 0. And then C would be just the number of negative 4. Okay, where we're going to start is we have what is called the parent function. And that is y equals x squared. We're going to start off graphing by using a table. So if we are graphing the parent function, what it means for the parent function is that is the basis for everything else. Eventually you'll see that this parent function, it'll change a little bit because of numbers in front. The A is going to change, maybe the B's and the C's are going to change. So your main function is going to either start getting wider or start getting narrower. So we're going to learn about that probably the next lesson. So if I were to graph this by a table, and if I plug in values for x and y, if I put a 0 in for x, 0 squared is 0. When you are doing, when you are graphing quadratics, you're going to want the vertex somewhere, and then you're going to want at least 2 points on either side of that vertex. So 0, 0. If I plug in a 1, I get a 1. So 1, 1. If I plug in a 2, you get a 4. And if I plug in a 3, I get a 9, because 3 squared is 9. So 3 and I'm probably going to be clear up here somewhere. Well, there's half of my parabola. So here is my axis of symmetry, and I'll explain how to find that in just a second. But we know that we can find the other half because of the mirror image. So this is 1 unit away, so this is going to be 1 unit away. This is 2 and 4, so this is 2 and 4. This is mirrored, and then we're going to have a negative 3 and 9. Okay, so that is what the parabola looks like. Make sure when you're graphing that your parabola does not look like a V, because that is a different kind of graph dealing with absolute value. So make sure you don't have that. Okay, so if we have, let's find a good one. Let me find it. Let's see. Okay, so if I have y equals 3x squared plus 12x plus 4, and we want to graph this. First thing you're going to do is find your A and your B and your C. A would be 3, B would be 12, and C then would be 4. We need to find our vertex. So in order to find the vertex is also known as the ordered pair of H, comma, K. Don't ask me where it came from. I don't know. It's probably some Latin term somewhere, but anyway, it is H, comma, K. So we have to find H and K. In order to find H, it is the formula of the opposite of B all over 2 times A. So H equals, my B is 12, so the opposite of B is a negative 12. 2 times my A, which is 3. If I simplify, I get negative 12 over 6, which gives me an H value of, an H value of negative 2. In order to find K, we have to plug this value in to this equation. So I have to find K, which is also my Y, equals 3 times negative 2, that is squared, plus 12 times a negative 2, plus my 4. So all I did was take my H value and plug it in for, which is also X, plugged it in for all of my X's into my original equation. The most common error is right here. Exponents come first, so negative 2 squared is a positive 4. Gives me a negative 24 plus a 4. So 12 minus 24 plus 4 gives me negative 12 plus 4 gives me a negative 8. So my H, my vertex is my H and my K. Oopsie. So that means that my parabola is going to have a vertex at negative 2, negative 8. Negative 2, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so there's my vertex. Once you've established your vertex, you can draw the axis of symmetry. Okay, so my axis of symmetry would have an equation of x equals negative 2. My axis of symmetry is whatever my H value is. Excuse me, that's a 2. Okay? So I know that it's going to either open up or open down. The A, if it is positive, that means that it opens up. If it is a negative number, it opens down. So this is a positive 3, so I know my parabola is going to be opening up. In order to find the other ones, I'm just going to start plugging in numbers in an X and Y table. Okay. When you are plugging in numbers, you don't want to go, okay, so like right now we're at X is negative 2. You don't want to jump clear over here to 5 because it's going to be a really high up here. So you take one itty bitty step at a time. So if this is X is negative 2, let's try where X is negative 1 and plug that in. So if I change this to 3 times a negative 1 squared plus 12 times a negative 1 plus 4. Negative 1 squared is 1 times a 3, so it's 3 times 1. This gives me a negative 12 and a plus 4. 3 minus 12 plus 4, negative 9 plus 4 gives me a negative 5. So when I put X as negative 1, it gives me a negative 5. 1, 2, 3, 4, and 5. Remember, we do not have to plug this one in of a negative 3 because it's going to be mirrored because of my axis of symmetry. If I plug a 0 in now, I'm going to go ahead and put this in my table. So negative 1 and negative 5 as well. I'm going to plug in a 0. This one's usually pretty easy. This is going to make this 0 and this 0, so it gives me a 4. So 0 and 4. and mirror it. And my parabola is going to look like that. Okay, so that is the beginning of parabolas. When we are talking about intercepts, this would have two x-intercepts because it intersects the x-axis twice, and the y-intercept, and we're going to learn how to find the x-intercepts, but that's another lesson. The y-intercept here is wherever it crosses, which would be the order pair of 0 and 4. Okay, and then we'll also talk about domain and range as well. So that concludes this lesson.